Alright, now I know I said I wouldn't be using the PowerPoint as much anymore after chapter 12, what chapter 3 was. But chapter 4, it kind of requires it. Okay, so this will be the last time you probably won't see the PowerPoint again. This will be kind of a long lesson because I'm going through the PowerPoint. But with chapters 6, 7, 8, and 10 left, which probably I'll do 8 and 10 on the same day. Or use 7 and 8 on the same day. I'll do one of those two on the same day. This will probably be one of your longer lessons, or longer videos. So we get straight to it. I'm going to do 4.1, and then I'm going to go to the homework for 4.1, and then I'll do 4.2 and do the homework for 4.2. So let's get started. Now I'm going to kind of skip through this, so feel free to download the PowerPoint. Now we're only doing 4.1 and 4.2. The PowerPoint itself, I think, covers 4.3 and 4.4 as well, maybe even more. But we're only going to do the first two sections for chapter 4. Okay. So, again, introduction to probability. We're going to identify sample space of a probability event, calculate basic probabilities, determine if two events are mutually exclusive, and determine if events are independent. And there's something we need to add here, so I'm going to add that in writing. Turn my pad on. So something else. We're going to determine subjective classical or empirical. I may have misspelled that, so I think that's an I there. Probabilities. Okay, so we're going to do this as well. This is actually going to cover a good portion of chapter 1. I don't know why it's not included in the objectives, but we're going to talk about these three types of improbabilities and how to identify which one is which. So they're going to ask you, what type of probability is this? So it's either subjective, classical, or empirical. Okay, now I usually use the word experimental instead of empirical. But they like to use the word empirical. Okay. So let's move on. So a probability experiment or trial is any process in which the result is determined by chance. Again, feel free to pause the video and write this down if you want, but I'm just going to read this and move on, okay? Each individual result that is possible for a probability experiment is called an outcome. Okay, for example, if you flip a coin, the probability experiment is flipping the coin, and the two outcomes are heads or tails. The sample space is the set of all possible outcomes. So the sample space would be heads or tails, so heads, comma, tails. Okay, an event is a subset of outcomes from a sample space. Okay, so let's talk about probability experiments. Let's say that you have, kind of put this in perspective. Say you just roll a die. Okay, not two dice, just roll one die. And each individual result, so you can get a 1 or a 2, and dot, all the way down to 6, okay? Each is a single outcome. So how many outcomes? 6 outcomes. Okay. A sample space would be list. Sample space would be all the different outcomes. So this would be the sample space. We usually denote that with a capital S. So capital S is equal to the list of all possible outcomes. An event, so E, capital E, an event is a subset. So it could be something like roll an even number. Okay. Or an event could be roll a number greater, and my handwriting, greater than 4. So that'd be a 5 or a 6. So these are events that are subsets. They just contain parts. So that would be a 2, a 4, or a 6. That would be the event. And this would be a 5 or a 6. That would be the event. Okay, so I'm just trying to put all these terms in perspective. Okay, flipping coin, trade die, rough ticket, da da da. Alright, so consider an experiment in which a coin is tossed and a 6-sided die is rolled. List the outcomes, and then list all outcomes of tossing a tail and then rolling an odd number. Alright, so here's all the outcomes. You can get a heads and a 1, 2, 3, 4, 5, 6, or a tails and a 1, 2, 3, 5, 6. So there's 12 outcomes. Basically, to get the how many outcomes you have, you basically just multiply the two separate outcomes together. When it comes to a coin, oops. All right, when it comes to a coin, you have 2 outcomes, and a die, you have 6 outcomes, so multiplying together, you get 12 outcomes. So, 12 outcomes. If you're asked to roll 2 die, that will be 6 times 6, or 6 squared, 36. Okay. Give me a second, I gotta take care of my little girl. Alright, so sorry about that, I just had to take care of a diaper, so. Alright, I don't know where I left off at, so I'm just gonna move on from here. I think we're just talking about how to determine how many sample spaces there are. I think, let me kind of take note of this. There's one question in your homework that's gonna ask you to find the probability of getting all tails when flipping a coin a certain number of times. Let's talk about that question real quick. We'll see it in the homework when I practice it anyway, but I want to talk about it now. All right, when it comes to flipping a coin, how many outcomes are there? Well, there's only 2 outcomes, heads or tails. But if I flip it 9 times, let's just say this is the one I'm going to do 9 times, that is 2 times 2 times dot 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 times 2. Easier way to write it is 2 to the 9th power. That is how many outcomes you're going to have. Now, 2 to the 9th power, I want to say is pretty large, so let's get the calculator out. So we have 2, and then the exponent button, 9th power, enter, 512. Okay, so that is my denominator. When it comes to, it says getting, what does it say, all tails, 9 times. Well, there's only one way to get all tails, and we just said the denominator, the total number of outcomes, was 512. Now we'll talk about probability a little more in just a second, but since we're talking about sample space, how you find the denominator is basically the sample space. The entire sample space is the denominator. Okay, so there's only one way to get all tails, okay, and that's just get them all in order. And there's 512 different ways you can have outcomes when flipping a coin. So there it is. There's how to do that question. We'll look at it in a moment. In a little bit. All right. So this part 2 here was given this specific sample space, or this specific event. Okay, tossing a tail and rolling an odd number. Well, that means you're going to get a T, and there's only 3 odd numbers, so it's going to be T1, T3, and T5. Okay. Consider an experiment in which a red 6-sided die and a blue 6-sided die are rolled, and we already said if you roll 2 die, it's 6 times 6, 36 outcomes. Here's the sample space, by the way. It's over here. It looks like this. This is all 36 different outcomes of rolling 2 separate die, and it is easier to think of it as 2 different color die. That way we can separate a 2 and a 1, or a 1 and a 2. A lot of people say they're the same thing, but they're not if they're different colored. Yeah, a little bit easier to see that they're different colored anyway. Right. So I'm going to move on. A tree diagram can be useful. It's kind of a pain, but you can do one. I don't think you're going to have to do one on the homework, so I'm just going to move on. Not going to stress it too much. Well, let me go ahead and go through it. So this is finding the sample space for a family with 3 children and write a sample space for the genders of the child. And we're just going to go with the biological gender of girl or boy. Okay, so here we have their first child could be a girl or a boy. All right, and then after that, if they had a girl, their second child could be a girl or a boy. If they had a boy, their second child could be a girl or a boy. So right at this point, their second child, there's 4 different outcomes: either a girl and a boy, 2 girls, girl and a boy then a girl, are two boys. And again, order is important because, yeah, you can't just say I have a boy and a girl. One's going to be older than the other one. Okay, so one's going to come first. So there's a difference between girl, boy, and boy, girl. Those are two separate outcomes. Now, for the third child, you could have a girl, another girl, or a girl, another boy. A girl, boy, another girl, or a girl, boy, another boy. So there's 3 girls, 2 girls and a boy, boy, girl, and then a girl and 2 boys. Or you can have a boy and then 2 girls, a boy and 2 girls, a boy, girl, boy, girl, boy, boy, girl, or boy, boy. So this is a tree diagram. It's basically, as you progress, we can go one more if you want. Here we could have a boy, a girl or a boy, and we can have a girl or a boy. We just basically keep drawing the stems or the stems down and labeling them girl, boy. Now usually with tree diagrams there's only 2 outcomes, so we could do that with a heads, tails, hit, miss, true, false, or girl, boy. Okay, so here we have there girl, boy, girl, boy, girl, boy. And you're going to notice that the number of outcomes doubles as you go. So 2 outcomes, 4 outcomes, 8 outcomes, 16 outcomes. Because again, how many different outcomes are there? 2. So you just keep multiplying by 2. 2 times 2, 2 times 2 times 2, 2 times 2 times 2 times 2. Or 2 squared, 2 cubed to the 4th power. All right. All right, so this is what I mentioned: subjective, experimental, and classical. Now on the homework, I don't know why this is their PowerPoint, so I don't know why they like to use empirical probability instead of experimental probability on the homework. You'll see it when we go over it, but they want you to at least understand the 3 different types of probability, and then be able to pick them out when they give you a certain situation. So first, subjective probability, it is educated guess, and it's going to usually require some type of expertise involved. Okay, so basically it's like the weatherman. Okay, a weatherman gives subjective probability because it's going to be based upon his expertise, his expert opinion. And whether it's right or wrong, it's supposed to rain today. It might have rained today, I don't really know. Or it may have rained last night, not today. So another one could be like a stock market broker. They could say what's probably going to happen in the next couple of weeks or next couple of months or what they expect to happen. But it's all subjective. It's all based on their opinion. So it's the least precise type probability. We're not going to calculate ever subjective probability. Okay. So here's an example. Yeah, the weatherman. Okay. Now, experimental probability, here's the difference. You're going to deal with experimental probability and you're going to deal with classical probability. Here's the difference. Experimental probability, you actually have to collect data. Okay? Data must be collected. Data must be collected. All right? So, if you can do 2 situations. If I flip a coin, what's the probability of getting heads? Well, we know it's 50-50. That's not experimental probability because I didn't flip any coin. I just know there's only 2 outcomes and one of them's heads, so 1 out of 2 is 50-50, 50%. Okay? So in order to experimental probability, I have to actually flip the coin. Okay? And now I can flip it 10 times. Okay? Or I can flip it 100 times. Or I can flip it 1,000 times. All right, now if I flip a coin 10 times, am I going to always get 5 heads and 5 tails? No, I probably won't get 5 heads and 5 tails, okay? But there's a good probability of getting 5. We're not going to go with that, but we're not going to talk more about that. But that's the idea, is we're not going to always get exactly 50-50, okay? Now flip it 100 times, I'm probably going to be closer to 50-50 than I would with just 10 times. If I flip it 1,000 times, even closer. Now this is what's known as, what's on the next page, which is the law of large numbers. Okay, it says the greater number of trials, the closer to experimental probability is to the true probability. Okay, which is what we actually call the classical approach, what the probability should be. Okay, so again, if you flip a coin, it should be getting heads is 50%, getting tails is 50%. If you roll a die, you have a fair die anyway, you have a 1 out of 6 of getting any specific side. So no data has to be collected. It's just basically the number of successes, okay? So, for example, you could probably find, what's the probability? I keep doing that. Keep not seeing that. All right. So what's the probability? And this usually they use just capital P with a parentheses, of rolling an odd number. Now, we already said that the outcomes of rolling an odd number, okay, since there's only 6 sides, the total number of outcomes is 6, so that's your denominator. And then how many odds are there? How many actually quantify as an odd number? We have 1, 3, and 5. There's 3 odd numbers. So you have a 1 out of 2 if you reduce, or 0.5 or 50%. It depends on how they want you to answer the question. They're all the same thing. Always reduce your fractions though, by the way. So either 1/2, 0.5, or 50%, all that's fine. So that's classical. I didn't have to roll die. That's just what it should be. Okay. Now, if I actually rolled the die and then collected data that way, then that would be experimental. Okay. Again, the difference between classical probability and empirical or experimental probability is the fact that experimental probability data must be collected, and classical probability, it's basically theoretical, what I call theoretical probability. It's what it should be with no data collection. Okay, it's basically what you want to occur over a total number of outcomes. All right. Okay, so probability of selecting Queen of Spades out of a well-shuffled standard deck of cards is 1 out of 52. Now, is that subjective, experimental, or classical? Well, that's classical, because I didn't collect any data there. That's classical. An economist predicts 20% chance that technology stocks will decrease or value. That is subjective, because, again, that's based on his expert opinion. And then a police officer wishes to know, probably the driver chosen at random will be driving under the influence of alcohol on a Friday night. At a roadblock, he records the number of drivers stopped, the number of drivers driving with a blood alcohol level over the legal limit. He determines the probability is 3%. So since data was collected, that is experimental or empirical probability. All right. So here we have calculating probability. Here we have, and I'm going to write this in a way that they're going to see on the homework. I'm not going to put it in a paragraph. I'm going to put it in a chart. So we have chocolate, which was 10, caramel, which was 12, and then we have peanut butter chocolate, which is 12, and then strawberry, which was 8. So these are the different types of cheesecake. And if you remember, this is the frequency. Right? So if I want probability, and see here, Beck's allergic to peanuts, what's the probability that he's going to pick something and he's going to be allergic to it? Well, there are, if you add this up, the total, 8, 20, 30, 42. So probably he's allergic to it would be 12 out of 42, which reduces to 2 out of 7. All right. So this is probability of peanut butter being in it. Probability of getting chocolate, anything with chocolate in it, that would be 10 plus 12, so that would be 22 out of 42, which is 11 out of 21, doesn't reduce anymore. Okay. So this is what would be experimental, or no, classical probability, because these are the different outcomes. Okay, he didn't actually have to risk getting an allergy. We didn't collect any data there. These are just the total number of options. Here's my total number of choices. These are how many meet certain requirements. How many are just chocolate, how many are caramel, how many are peanut butter and chocolate, how many are strawberry. Okay, so there we go. And that's what a lot of your questions are going to be like. It's that easy. Moving on. I'm not going to mess with that. Not mess with that. I think we're done here. Yep. All right. So let's look at the homework here. All right. Nope, I wanted to do. That's fine. So coin is tossed 8 times. What's probably getting all heads? Now this is that question I mentioned before. This is classical probability. All right. So it is basically how many outcomes meet the requirement. And there's only one outcome. If I flip a coin 10 times, there's only one way I'm going to get all heads. So what they call the number of successes, if I spelled that correctly, which I don't think I did. I think that's better. Over total outcomes. Spell that backwards. Right. So, again, there's only one way to get all heads. Now, we mentioned before how to find the total number of outcomes, how to find your denominator. There's 2 outcomes on flipping a coin, and I'm flipping it 8 times, so to the power of 8. So I want to say that's 256. Yeah, 256. So 1 out of 256. Now to put that in here, again, you have your keypad, which gives you your fraction button, and 1 over 256. And there we go. All right, so here we go. Another, again, it's going to be fractions, so I'm going to just keep putting fractions in there. All right. So here they want to know, we decided to record hair color people in your lecture at school was probably the next person who leaves the lecture will have black hair. That means that's my numerator, 24. All right. The denominator is how many there are total. The denominator is always the total. So I'm going to add that up. I'm going to put it over here, 37 plus 47 plus 33 plus 24 plus 39. Enter. Now that is my denominator. Now you're going to notice if I put 180, it's going to come back with a blue box saying not simplified. All right. So we need to simplify it. Now to do that, easy way to do it is just put in your calculator. And feel free to do it by hand. Go right ahead for those who really feel like just going the extra mile. But don't waste your time. Put in the calculator. It gives you 2 out of 15. Basically, all you do is type in the fraction in and press enter, and it automatically gives it back to you in reduced form. So there you go, 2 out of 15. Okay, we're good. All right, so just saying, oh, this same question, just different numbers. So again, we did it already. Okay, standard 6 dice roll was probably rolling a number equal to 2. All right, so a standard 6, so only 6 outcomes. That's my denominator, 6. All right, so my denominator is 6. And how many are just the number 2? Only 1 outcome, that is number 2. Now you have to be careful with this because I don't know if another one's going to pop up like this, but it says equal to 2. Your question, let me see if it's going to do something that's different, but your question may be greater than 2 or less than 2 or less than or equal to 2, so be careful. All right, so try similar. See, here we go, less than 5. So when you put the fraction in, 6, how many numbers are less than 5? Well, 1, 2, 3, and 4. There's 4 numbers less than 5. Okay, now you have to reduce that, and this reduces by 2, so 2 out of 3. All right, there you go. But you'll have a question like that. All right, so box contains 57 red marbles, 9 white marbles, 58 blue marbles. So if we add all this up, we're going to need a total anyway. So if I add this up, I'm just gonna put that in my calculator. 57 plus 9 plus 58, 124. So 124 is my denominator. Marbles random selected, what's the probability it is red or blue? Now, red or blue means either one is okay, or just means you add them together. 57 plus 58, which would be 115, which I think should reduce. Yeah, I'm going to say that's going to reduce. I'm going to put that in the calculator. So 115 over 124. Nope, does not reduce. Okay. There we go. Glad I checked, though. Alright, so here's the question. Is this classical, empirical? I said they like empirical. On the PowerPoint, it's experimental. Okay, just know that empirical is experimental. That's the same thing. Both begin with E. You calculate the probability of choosing a student who is left-handed is about 47%. So I did not collect any data. Okay, nothing was collected. That is classical probability. No, explain error. It's not subjective, so it has to be empirical then. All right. It's kind of poorly worded because they didn't mention collecting any data, but I'm guessing you would have to collect data, so I'm glad we went over this. Because if you get this question, just note, you would have to collect data, all right? Because to be honest, left-handed people is about less, I would say less than 10%, maybe around 10% of the people, population is left-handed. So if you have a close half your class being left-handed, that's pretty impressive. So I'm guessing you would actually have to collect data. So calculate probably as randomly chosen student who is left-handed, about 47%. So I'm guessing you would have to collect data for that because that's not the true percent. All right. So that's a guess. It's kind of poorly worded. They should give you a better question. All right. Aha. All right. Now, here we go. Write out the sample space. Now, they want you to write out the sample space for this, and it's really not too bad. Let's actually write this out. All right. So you are having a salad, okay? And you are asked if you want olives or asparagus on your salad, or eggs, or turkey. There's olives or asparagus, and then you choose between protein, either eggs or turkey, and then dressing, Italian or vinaigrette. So you have basically two choices. So you could choose olives with, so we're going to start with olives, with eggs, and then lastly with Italian. And then we can choose olives with eggs with the vinaigrette. Or you can choose olives with turkey with Italian, or olives with turkey with the vinaigrette. Okay, so those are really your only options you have there. Okay, that's it for olives. Olives with eggs, olives with turkey, Italian vinaigrette. Now, what if you chose asparagus? You could choose eggs with Italian, or you can choose asparagus with eggs with vinaigrette, or you can have asparagus with turkey and Italian, or asparagus with turkey and the vinaigrette. So they want you to type that in with a comma in between each. So let's show you that. So we got it written up here. Capitalize everything. O-E-I, comma, O-E-V, comma, O-T-I, comma, O-T-V, A-E-I, comma, A-E-V, A-T-I, and then A-T-V. And there we go. You believe you have a 1 in 13 chance of drawing a 6 from a standard deck of cards. That's definitely classical because again, you're not collecting any data. There's 4 6s out of 52 cards, so that reduces to 1 out of 13. That's classical. All right, what's probably rolling the sum of 3 in a pair of 6-sided die. Now, it might be helpful to have this PowerPoint. You go all the way back here to where you get the sample space for die. Okay, there's only 2 ways you can get a sum of 3. 2 and a 1 or 1 and a 2. Okay, so it might be helpful to have this. Let me see, I don't think they give us the option here. I don't really have it. But everything's open notes, so I would have that as a note. Okay, so there's 2 ways. So there's 2 out of 36, which does reduce to 1 out of 18. Almost done. There are 268 identical plastic chips numbered 1 through 286. So how many different outcomes are there? Hopefully you said 268 outcomes. What's the problem reaching into a box and randomly drawing a chip number that is smaller than 86? So how many numbers are smaller than 86? Well, there's 85 smaller than 86. And that's it. Let me put in the calculator to check to see if it reduces. Okay, let's put that in the calculator. 85 over 268 doesn't reduce. So 85 over 268, mid answer. Now be careful because again, this can change. You could say greater than 86 and then you'd have to subtract, okay? Because I didn't know how many numbers are greater than 86. So you do 268 minus 86. Okay, now if it says equal to a number, that's just 1. Okay, smaller than that, so that smaller is fine. Smaller, these all seem to be smaller, so we seem to be okay on these. All right, skip. All right, let's clear this. So you believe you have an 8% chance of getting to an accident your way to the movies. Being that we live in St. Louis, it's probably a lot higher. If you're going to the movies right now, good luck, because you're not getting in. All right, 8% of that is subjective probability, because there's no real science behind that. There's no real way to collect data behind that. So yeah, subjective probability. And that's it for 4.1. That's all the homework on that. So what I would do right now is I'd go do 4.1 if you're not doing it as we do this. And then get started on 4.2.